BYD just confirmed that their next generation blade battery is coming sooner than we thought, in a few weeks actually.
BYD is now bigger.
Industry. This new technology goes far beyond a simple upgrade. It marks a transformative shift in EV battery performance. With faster charging, a longer lifespan, enhanced safety, and reduced costs, BYD's latest battery could set a new global standard, forcing competitors to either evolve or risk being left behind. Despite its significance, this development hasn't yet captured widespread attention. But make no mistake, this isn't just a minor technical improvement. It represents a seismic leap forward that could make electric vehicles more accessible, reliable, and sustainable than ever before. The real question now is how the rest of the industry will respond to this disruptive innovation. Since its debut in 2020, the Blade battery has already made a significant impact. Unlike traditional nickel-cobalt-manganese (NCM) batteries, which are expensive, resource-intensive, and prone to overheating, BYD's lithium iron phosphate (LFP) chemistry offers a safer, more affordable, and longer-lasting alternative. While the first-generation Blade battery set a high benchmark, this new version pushes the limits even further. Years of research and refinement have led to advancements that are not just evolutionary, but revolutionary. One of the most significant improvements is the increase in energy density. The second-generation Blade battery now delivers 190 Wh/kg, up from 150 Wh/kg, a remarkable 27% increase. This means EVs equipped with the new battery can travel longer distances on a single charge, without increasing the size or weight of the battery pack. For drivers, this translates into greater range confidence and less worry about finding the next charging station. Charging time has also seen a substantial upgrade. With a 110 kW DC fast charger, the battery can charge from 30% to 80% in just 30 minutes. This directly addresses one of the biggest concerns for EV owners: long charging durations. Imagine stopping for a quick coffee and coming back to a car that's ready to hit the road again. This kind of convenience is a game-changer for the EV experience. In addition to performance improvements, BYD has achieved notable gains in cost efficiency. By streamlining its manufacturing process, the company has reduced production costs for the second-generation Blade battery compared to its predecessor. These savings can be passed on to consumers, resulting in more affordable EVs and accelerating the global transition toward electric mobility. For years, automakers such as Tesla, General Motors, and Volkswagen have relied on traditional lithium-ion batteries that use expensive materials like cobalt and nickel. While energy-dense, these batteries come with significant trade-offs, including high costs, supply chain risks, and safety issues. BYD's LFP technology eliminates those concerns entirely. By removing cobalt and nickel, the Blade battery becomes not only more cost-effective but also safer and more durable. This gives BYD a significant advantage, enabling it to produce high-quality EVs at lower prices. Tesla has already acknowledged the benefits of LFP chemistry by incorporating it into some of its entry-level models. However, BYD's years of development give it a commanding lead in the battery space. As the global demand for sustainable transportation grows, LFP batteries are poised to become a preferred solution, and BYD is well-positioned to meet that demand. Ultimately, BYD isn't just keeping up with the competition, it's setting a new benchmark for the entire industry. Its success is rooted in relentless research and development. Since launching the first Blade battery, the company has remained committed to making its technology safer, more powerful, and more accessible. The result is a battery that outperforms its predecessor in every meaningful way. A key factor in the new battery's improved performance lies in its enhanced energy density. Traditionally, LFP batteries lagged behind nickel and cobalt variants in this area, often requiring larger packs to match driving range. But BYD's optimized chemistry now allows for more energy to be stored without increasing the battery's size or weight, a major milestone. This leap forward is also attributed to better materials and improved thermal stability. The second-generation Blade battery uses refined raw materials that generate less heat during operation, improving both efficiency and safety. Less energy is wasted as heat, and the battery's reliability and longevity are significantly improved. Charging speed remains one of the final hurdles for widespread EV adoption, and BYD has made clear strides in addressing it. With its enhanced charging capability, greater energy density, and lower costs, the second-generation Blade battery may very well shape the future of electric mobility, not just for BYD, but for the entire industry. While advancements in battery technology have extended the driving range of electric vehicles, EVs, long charging times still remain a major drawback, making EVs less convenient compared to gas-powered cars. However, BYD's next-generation Blade battery is set to change that. With an optimized structure and refined LFP, lithium iron phosphate, chemistry, BYD engineers have successfully reduced internal resistance. This advancement enables significantly faster charging without generating excessive heat. As a result, EVs equipped with this battery can charge from 30% to 80% in just 30 minutes using a 110 kW DC fast charger, bringing charging times closer to the convenience of refueling a gasoline vehicle. In addition to faster charging, the second-generation Blade battery also improves overall driving range. With a 27% boost in energy density from 150 Wh a kilogram to 190 Wh a kilogram, BYD has extended travel distances without increasing the battery's size or weight. This means future EVs powered by this battery could potentially exceed 600 kilometers on a single charge, depending on vehicle design and efficiency. While most EV battery innovations focus on either range or charging speed, BYD has managed to make significant gains in both areas simultaneously. This results in fewer stops at charging stations, more time on the road, and an EV experience that rivals the convenience of traditional vehicles. Safety has always been a critical concern for EV batteries, especially those using nickel and cobalt-based chemistries. These batteries are known to become unstable under extreme conditions, sometimes leading to fires or even explosions. In contrast, BYD's Blade battery is engineered with safety as a core priority. It stands out as one of the safest battery technologies available today. A key demonstration of this safety is the nail penetration test, which simulates what would happen during a serious car accident. While many conventional batteries catch fire or explode under this test, BYD's Blade battery remains stable, showing no signs of ignition or overheating. The exceptional safety performance of the Blade battery is attributed to its unique LFP chemistry. Unlike traditional batteries that release oxygen during a breakdown, creating a flammable environment, BYD's battery does not trigger such reactions. Even when physically damaged, the Blade battery maintains its integrity, reducing the risk of catastrophic failure. Beyond the nail penetration test, it has also passed a range of extreme stress scenarios, enduring overcharging by 260% without overheating, exposure to temperatures exceeding 300 degrees Celsius, and being crushed under the weight of multi-ton vehicles. Additionally, long-term testing has shown minimal degradation over time, confirming its durability and reliability. What makes this achievement even more impressive is that BYD has enhanced both safety and performance without compromise. In an industry where safety is often sacrificed to achieve higher energy density, BYD has proven that it is possible to achieve both. This focus on reliability will resonate strongly with consumers, many of whom remain hesitant to transition to EVs due to battery safety concerns. The Blade battery's unmatched stability offers peace of mind and sets a new benchmark for the industry, paving the way for more widespread EV adoption. Another major barrier to EV adoption has long been cost. Despite falling prices, EVs remain considerably more expensive than their gas-powered counterparts, largely due to the high cost of battery production. BYD's second-generation Blade battery could change that permanently. By refining its manufacturing processes and eliminating costly materials like cobalt and nickel, BYD has dramatically reduced production costs. This means more affordable electric vehicles, making EV ownership accessible to a broader segment of consumers. BYD's innovations are not just about price, they're about strategic foresight. While automakers such as Tesla, Ford, and Volkswagen continue to grapple with battery supply chain issues, often relying on scarce and expensive materials, BYD has taken a radically different approach. By focusing on the more abundant and sustainable LFP chemistry, BYD has positioned itself as a leader in scalable, cost-efficient battery production. While competitors scramble to secure essential raw materials, BYD is already mass-producing its next-generation blade batteries at a lower cost, allowing it to offer EVs at more competitive prices. This cost advantage could reshape the competitive landscape of the EV market. Budget-conscious consumers are likely to be drawn to more affordable EV options, especially in markets where price remains a primary purchasing factor. If legacy automakers like Tesla, Volkswagen, and General Motors hope to keep pace, they may need to rethink their battery strategies. Without similar innovations in battery cost and safety, they risk falling behind, while BYD continues to carve out a dominant position in the global EV space. Affordability is more than just a key selling point for electric vehicles, it's a gateway to transforming entire industries. BYD's blade battery is not only reshaping the EV market but is also poised to revolutionize renewable energy storage. Thanks to its higher energy density and lower production costs, this battery could make large-scale solar and wind energy storage more practical and affordable. One of the biggest challenges with renewable energy is its intermittency. Solar panels only generate electricity when the sun is shining, and wind turbines only operate when there's wind. A high-capacity, ultra-safe battery like BYD's blade battery could be the crucial link that makes round-the-clock renewable power a global reality. BYD already has a strong presence in energy storage beyond automobiles. Its battery systems are used in homes, businesses, and even citywide grids to store excess energy for later use. With the improved energy density and cost efficiency of the second-generation blade battery, BYD's storage solutions could become even more competitive, offering an edge over existing technologies. This advancement comes at a pivotal time, as governments worldwide set ambitious clean energy targets. The European Union, China, and the United States have all committed to drastic carbon emission reductions in the coming decades. Reliable, affordable battery storage is essential to achieving these goals, and BYD is emerging as a key player in making that possible. The global race for battery innovation is intensifying. Tesla, Volkswagen, and other major automakers are investing heavily in next-generation battery technologies, but BYD has already taken a significant lead. For instance, Tesla's highly anticipated 4,680 battery cells have faced production delays and technical setbacks, while BYD is already mass-producing its second-generation blade battery. If other companies can't catch up in terms of cost efficiency and manufacturing scale, they risk losing their footing in both the EV and energy storage markets. The competition between BYD and legacy automakers is reaching a critical point. While traditional brands like General Motors, Ford, and Volkswagen grapple with scaling up EV production and managing supply chain bottlenecks, BYD is moving swiftly and strategically. With the ability to manufacture vehicles faster and at lower costs, BYD could soon become the world's top EV manufacturer. What sets the company apart is not just its innovation but its readiness to meet global demand. BYD isn't limiting its vision to just selling more cars. The company is expanding its global footprint by investing in international manufacturing facilities. Plans are already underway for new battery factories in Europe and South America, moves that will help reduce production costs further, shorten delivery times, and avoid potential trade restrictions. This global expansion reinforces BYD's position as a dominant force not just in electric vehicles, but in the broader energy transition. As these developments unfold, the question becomes increasingly clear: can competitors keep pace? Or are we witnessing the moment when BYD officially takes the lead in the EV revolution? The future of transportation is being rewritten, and BYD's blade battery is at the center of this transformation. With its superior safety, longer lifespan, and affordability, this battery represents the biggest leap in automotive technology since the invention of the car itself. Looking ahead, the impact could extend well beyond the automotive industry. We may soon see a world where electric vehicles dominate roadways, cities are powered by renewable energy, and battery breakthroughs continue to push the boundaries of what's possible. Could BYD's blade battery be the game changer that redefines not only how we drive, but how we power our world?